Saxon's Calculus, Lesson 52, is about the derivative of a quotient and then proof of the quotient rule, which I will likely skip. So we had a multiplication song that helped us to understand what to do when we were multiplying. And now we have a new song for what happens when we are dividing. So just again, when we multiplied, it was 1d2 plus 2d1. Now on this song, it's all I wanted to sing was the quotient one because that's what I just said. Low, D high, and this is in the box on page 258, minus high, D low, because you've got things in the numerator and things in the denominator. That's where this low and this high stuff is coming from. So low D high minus high D low over, and you can continue to write this in one statement as they did, or you can do it as the fraction. Either way, it's the same thing, over square of what's below. And I realize they did it to be sing-songy of what's below, but this is kind of how I shortcut it. So now in example 1, it says f of x is the natural log of x over 2x plus 3. And we are to derive. So we're going to follow low, meaning rewrite 2x plus 3, and then the derivative of the high, so the derivative of natural log is 1 over x minus, and then the high one is natural log of x, and the derivative of the low one is 2, and then all over top of 2x plus 3 squared. And I'm wondering if, they do fix one thing here. They left their 2x plus 3 at the top, but this 1 over x, they said, even though it's just multiplying with this part, they're going to put the x underneath. I don't like that necessarily, so I would leave it alone. Oh, just a second. Did I lose an x? They have 2. Make sure I'm reading the right one. They wrote minus 2x natural log of x over their 2x plus 3 squared. Let me see if I can find that. It was part of their fixing this x here. So what they said was, we don't like it here, so let's multiply every single piece by an x. So they ended up with an extra x down here, which I was picturing they were just moving it down, but they're not. That's why they have an x here. This is a perfectly acceptable derivative of that. It's just a difference in how they chose to simplify. Now, example 2. They give us find dx when we have x cubed minus 2x plus 2 over top of sine of x. So again, we're going to follow our song low, so sine of x, derivative of the top, which is going to be 3x squared minus 2, and then minus, rewrite the top, x cubed minus 2x plus 2, and the derivative of sine goes to cosine, all over top of the sine squared. And I seriously doubt they simplified sine x, the 3 minus the 2 minus their lovely parenthesis. Yep, that's absolutely as they wrote it. Okay, example 3. If y equals cosine of x over e to the x plus x, find dy over dx. So again, follow our song. Low, e to the x plus x, derivative of cosine is negative sine of x minus cosine of x, derivative of the bottom, remains e to the x plus 1, because the x goes to that, over top of e to the x plus x squared. And I doubt, other than maybe putting this in front, which they did, I don't think they're going to simplify anything else. Nope. All right, any others? Yes, example 4. Find the differential of y equals x over cosine of x. Now, because this said differential, I need to make sure that I put each of the labels with it as we go. So we're going to start with our cosine of x. Oh, wait, not dx, because I didn't do anything with that one. Derivative of x at the top is a 1, but that's going to go to then dx minus the x, which I'm not deriving, and then the cosine goes to negative sine of x, again dx attached with that, all over top of cosine x being squared. And the only change I could make with that is to separate these dx's, but since it asked for differential, I would just leave them there. They actually kind of pulled them out of the top and also implied that they had a dx with this one, but I didn't derive it. I was following the song square of what's below. So I would leave it here if it were me. Cosine x plus... Oh, I would make one small change here, though, because this was minus a negative. I would change that to be plus x sine x. Now, part B, the proof of course, what you're doing is you're plugging into that original f of x plus change of x minus f of x all over change of x, and you're doing that in fraction form, and you can see all of their massive simplification there until they get down to their lovely song rule, and I would say stick with the song rule.